ずはじめにプレゼンテーション1フレキシブルインターディジティテッドエレクトロのプレパレーション&アプリケーションニュータイペイミニシパルキョンハーシニアハイスクールからウェイ・レンヒーさん、指導はチャオ・ジンシュン先生です。それではどうぞステージの方へお進みください。どうぞよろしくお願いいたします。
Ladies and gentlemen, good afternoon. My name is Wei Chen, and I come from Taiwan, New Taipei City, Zhonghe Senior High School. And today I'm going to introduce my research, flexible interdigitated electrode preparation and application. And then I will call it IDE. And what is IDE? It consists of two independently microelectrodes striped with interdigitated electrode, and compact integration of electrode can promise lower driving voltage and higher sensitivity to surrounding the variation. And what chemical can the IDE sensor? It is about gas and metal ion and big biocompounds such as dopamine and insulin antibody. And this is our principle of IDE. C is capacitance, and the application is about dielectric constant, and is about the IDE sample. And the N is about the stripes number, and the capital K is IDE parameter, and it is about the IDE width and distance and so on. And the traditional IDE highly depends on chemical etching method, and this method which is harmful to human body and the environment, and it is cost a lot of time. So we have a new idea of IDE preparation, and it is gel printed. It is this method which is friendly to the human body and environment, and it also increases the cost time. And another difference is our IDE is the free labeling, which means I can detect what I want to detect. And this is our outline. First, I will introduce the IDE preparation. And second, I will show you my experiment. And third, I will introduce how to achieve chemical recognition by IDE sensor. And the last one is conclusion and the future work. And first, we use the silver pen to draw our IDE. And this IDE is the first generation. And first, we want to know the stripe number can impact the sensitivity. So as we can see in the chart, we enhance the stripes number, and when we enhance the stripes number, the higher the sensitivity. And because our first generation IDE is using by handcraft method, so it has many problems, so we have to improve that. So we use the robotic machine. And first, we put the homogenized silver gel into the syringe. And second, the pattern of IDE was determined by using software of dispenser so that the silver gel could be precisely printed on PET substrate, and which consists of 41 degrees. And with the help of robotic dispensing, our IDE could be automatically repeated. And finally, we want to fix the IDE shape. So we put it on the hot plate and heat at 120 degrees. and for 3 hours. And this is our second generation ID. It is as small as our finger, so it is very small. And as we can see in the picture, it's just 1 millimeter width and 0.5 millimeter distance. And see another picture, the preparation is very easy. We just put the IDE into the solution and connect the LCR meter by using AC frequency, and just it. And our second generation IDE, different from the traditional IDE, is about lower cost and easy preparation. And our IDE is impedance sensor, and our IDE is free labeling. And this is our second experiment. From using non-electrolyte to electrolyte and big biomolecule. And first, we choose the glucose to detect. As we can see in the picture, the chart, when we change the frequency, but the sensitivity didn't have any variation. So we just focus on the electrolytes and the big biomolecule. So we choose the sodium fluoride, and the axis is about the concentration, and the vertical is about the capacitance. When the solution in the low frequency, the detection limit is lower, but the sensitivity is not sharper than the higher frequency. And from the small ion to the big biomolecule, it has the same chance. And the big biomolecule, we choose the sodium glutamate, which is a food addiction. So as we can see this part, at lower frequency, the detection limit is lower. And at highest frequency, the slope is sharper. And we also know that the detection limit is effective from the small ion to the big biocompounds. So we can see this chart. These 6 different solutions have its specific slope set. Every solution has its unit sensitivity. So we can use this method to know the pure unknown solution. We just put the pure unknown solution on our IDE and check out all our data. So we can know the solution, what it is. And this is our conclusion. First, in this world, IDE has been successfully prepared using by robotic dispenser and shown good response to electrolyte solution. And second, each chemical has less specific slope set with a certain AC frequency that could achieve effective, pure chemicals recognition. And third, IDE can be used to plot not only small ion, but also large biocompounds. And because our IDE it is flexible, so we can put it on our human skin and detect for all day. And we also can connect our cell phone and to know our information of our body. And thanks to the Zhonghe University and my school and the National Taiwan University to help me complete this research. And thanks to the Osaka City University and the Japan Science and Technology Agency to give me a chance to show my research to everyone. And this is my country, Taiwan. It has a lot of food and drink, and it is very tasty, like beef noodle and boba milk tea. And we have a famous building, Taipei 101. And it used to be the highest building in this in the world. And the new Taipei city is surrounding the Taipei, and my school is in the new Taipei city, and it is the best school in the new Taipei city. And thanks for your listening.
ありがとうございました。それではせっかくの機会ですので聞いてみたいなとか、またご質問などございましたら手を挙げていただきましてお聞きいただければと思います。ご質問などいかがでしょうか。せっかくの機会ですので、ではマイクをお願いいたします。
My question is advantage of method when you compare to the normal lithographic technique. Because normal lithographic technique is already developed method to make a very small electrode. What is the advantage of your method compared to the typical lithographic technique?
Sorry, can you repeat it again?
You show us the already lithographic technique, that is masking and etching and washing process. You can make a very, very small electrode like your shape. But you said you have advantage, right? Compared to if you compare to your method and lithographic technique. I still can't understand what is your advantage of your method. Okay, your lithographic technique, it means etching technique. You compare the two methods, etching technique and your technique, all right? At the beginning of your presentation. Yes, can I go back? Back a little bit more. I think at the beginning of your talk, you compare the two methods. Okay, I've changed my question. I want to know about the selectivity. If you use a solution containing a lot of compound and ion, can you get the selectivity just detect some special compound or some special ion? Is it possible by using your method?
We can use the ID to detect the pure solution. Our detect error is just under the 5%, so it is very precise.
Thank you.
ありがとうございます。その他ご質問などはいかがでしょうか。もしございましたら挙手をお願いいたします。はい、ではマイクをお持ちいたします。
Thank you for your nice thought. I have just a simple question about the preparation procedure. Okay. So that procedure was originally developed by yourself, or you follow some known procedure?
I do this by my another partner, and not by myself. Yeah.
Okay, so in that case, you can give us some suitable reference. You can give us the suitable reference in your slide for the preparation of your device.
Sorry, I
Literature. Suitable literature. You can cite suitable literature in your slide, I guess.
嬉しいでしょうか。では時間が来ましたので、以上とさせていただきたいと思います。Wayne チェンイーさんでした。ありがとうございました。